Applications of stack. Stack is used by compilers to check for balancing of parentheses, brackets, and braces. Stack is used to evaluate a postfix expression. Stack is used to convert an infix expression into postfix prefix form. In recursion, all intermediate arguments and return values are stored on the processor stack. During a function call, the return address and arguments are pushed onto a stack, and on return they are popped off. Applications of queue. It is used to schedule the jobs to be processed by the CPU. When multiple users send print jobs to a printer, each printing job is kept in the printing queue. Then the printer prints those jobs according to first in, first out basis. Breadth first search uses a queue data structure to find an element from a graph. Let's see next the applications of linked list. Linked lists are used to represent and manipulate polynomial. Polynomials are expressions containing terms with non-zero coefficient and exponents. Represents very large numbers and operations of the large number such as addition, multiplication, and division. Linked lists are to implement stack, queue, trees, and graphs. Implement the simple table in compiler construction. Let's again and just repeat the applications of linked list. We have the first one, that is the linked list, that is used to represent and manipulate mostly polynomial. Polynomial means what? It is an expression which contains terms with non-zero coefficient and exponents. And the second one we have is it will represent very large numbers and operations of the large number such as addition, multiplication, and division. Linked lists are to implement stack, queue, trees, and graphs. And fourth one we have is to implement the simple table in compiler construction. Non-linear data structure. It does not arrange the data consequently, rather it arranged in sorted order. In this, the data elements can be attached to more than one element, exhibiting the hierarchical relationship which involves. So basically the relationship, like we can take a real example like child, parent, and grandparent. In the non-linear data structure, the traversal of data elements and insertion or deletions are not done sequentially. The non-linear data structure utilizes the memory efficiently and does not require the memory declaration in advance. There are common examples of non-linear data structure, tree and graph. Tree data structure organizes and stores the data elements in a hierarchical relationship. Let's see the applications of trees. First one is manipulate hierarchical data. Second one is make information easy to search. Third one is manipulate sorted lists of data. And fourth one is router algorithms. Applications of graphs is to find the shortest path, resource allocation graph, routing algorithms. Key differences between linear and non-linear data structure is the first point is in the linear data structure, the data is organized in a linear order in which elements are linked one after the other. As against in the nonlinear data structure, the data elements are not sorted in a sequential manner, rather, the elements are hierarchically related. I'll repeat the first point. In the linear data structure, the data will be organized in a linear order in which the elements are linked one after the other. And then when we compare it with the linear, non-linear data structure, the elements are not sorted in a sequential manner, rather the elements are kept in hierarchical format. Second one we have is traversing of data in the linear data structure is easy as it can make all the data elements to be traversed in one go. But at a time, only one element is directly reachable. On the contrary, in the non-linear data structure, the nodes are not visited sequentially and cannot be traversed in one go. Third point we have is data elements are adjacently attached in linear data structure, which means only two elements can be linked to two other elements. While this is not the case in the non-linear data structure, where one data element can be connected to numerous other elements. Fourth is the linear data structure are easily implemented relative to the non-linear data structure. Fifth one, a single level of elements is incorporated in the linear data structure. Conversely, non-linear data structure involves multiple levels. Sixth point, the key differences. Examples of the linear data structure are array and queue stack, linked list, etc. In contrast, data tree and graph are the examples of data linear data structure. The memory is utilized efficiently in the non-linear data structure. The linear data structure tends to waste the memory. Let's see the next topic, that is arrays. What is array? So when we take or talk about the definition of array, array is the one of the composite data structure which may be of n dimension. In other words, array is an ordered set of elements which are of same data types, having the infinite number of elements. The general form of array declaration will be data type, array name, size. Each element of array is referred by its index. The smallest value of array index is known as lower bound, and the largest value of array index is known as upper bound of an array. So what it means, like array is a ordered set of elements. So basically it has to be same data types which will be having finite number of elements, and we have to follow this syntax. Usually the number of elements that an array can hold is called as range or the size of an array, and is given by upper bound minus lower bound plus 1. Array can be passed to a function as a whole. Since an array variable in Z is the pointer base address of the array, while passing, it is passed by reference and not value. Let's see using one-dimensional array. So following is a simple example of using one-dimensional array. This program is to compute sum and average of n numbers. So let's see the first program, how it will be working. So we have the header files hash include stdio.h. The next header files we have is hash include con.io.h. So let's see, we'll go to the main function. We have void main, and then we will be declaring the array. Int a is the array which is having the fixed size n, and I sum is equal to 0. So we have an array which is of integer data type, a variable n, I, and sum which is initialized to 0.
I didn't catch that.
We have float average. So we have another variable of average, and we are clearing the screen. And we're going to take input from the user, where we are going to take the input from the user asking for the size of array. If we've used printf, we have to use scanf. Then the size is integer, so %d, and n is the size. After that size, we have to enter the elements depending upon the size of the array. Enter the elements. Again, we are asking from the user to enter /n so that it displays in the new line, or entry happens in the new line. And as one by one we are going to take set of elements, we're going to take it in a for loop where you have the initialization I is less than n, I plus plus, and then a of I. So as the program is finding the sum and average of n numbers, sum plus, so we are going to find the sum. So sum plus equal to a of I is nothing but sum is equal to sum plus a of I. And so the one criteria of the program is finished. Next thing is what we have to do is the sum of array is done. Now we have to find the average. So average, we are going to take it as float sum divided by n, and then we are going to print slash n sum, because we have to show the answer for the sum, and average, or we have to print the sum and average. As average, we are going to get the answer in float. Average. So let us execute and see how the output will be. Let's run the code. So let's see the output. Enter the size of the array. We're going to put it as, we'll just try with the simple one, 3, and enter the elements 1, 2, and 3. So we have the sum is equal to 6 and average is equal to 2. So let's see again. We'll take it for a bigger number. We'll take it, I think 5 would do. Enter the elements. It's not necessary that it has to be in sequence. 4, 5, 6, 7. It is the sum. Let's see array as parameter. Now let's see an example which will indicate how to pass an array, or we can, in other words, we can say that how a base address of the array is passed to a function. So let us use the same example. So the same example with the slight modification. We'll see here. Float. We're going to have a function which is defined outside the main. Average int x. So we're taking the array as a parameter. Int sum equal to 0, comma I. Float average, and then for I is equal to 0, I is less than n, I plus plus. Okay, and then we are going to add x of I avg equal to float sum divided by n. That is for the average, and then we are going to return AVG. That is average. Now the rest of the things is as per the previous. Instead of this, we'll just mention it as A. Enter the size of array. Enter the elements, and then okay. So instead of doing all these things, what we will do, because already it is defined, we are going to take the size and then we are going to call the function here. Is not here. A equal to avg a comma n. Printf slash n avg, as it is a floating one, so percentage f avg.